Lesson 3, we're graphing the square root function. So you guys are going to have to be able to graph, which is why we have rulers for today. So for prior knowledge, the objective is at the top of every slide too. Graph square root functions using transformations. So the prior knowledge for today, I want you guys to practice finding a, h, and k for the function. So if you remember the function, the function has the general form of like g of x equals a in the front times the square root of x, and then you have the minus h and the plus k. So don't forget you have to take the opposite of h. So for prior knowledge, looking at these three values, which one's the a, the h, and the k? And then don't forget h, you have to switch the sign. So talk to your group really quick. What would those three values be in this example? All right, so what did you guys say? A is what in this example? -3. Good. It's in the front. If you notice, -3 right here is in the front, so that's our A value. H, what did you guys say for H? -5, because this has to be the opposite of H. It's because of the negative in the front right there. It has to be the opposite of H. So you have to switch signs. If it was positive, you change it to negative. If it was negative, you change it to positive. Okay? And then our K value is at the end after the square root. So your K value, you should have had -4. Okay? I like to use color a lot. I don't know if you guys have noticed. Probably have. But A, I'm going to stick to red. H, I'm going to stick to blue. And then the K's, I'm going to stick to pink. Okay? Do you guys remember what each of those values does to the graph? Does anybody remember? No? Okay. So the A value tells you either if it's a vertical compression. Vertical stretch or compression. And then it tells you if there's an x-axis reflection, like if it flips. Do you guys remember when there's an x-axis reflection? When it's negative. Good. So if it's A is negative, then we have an x-axis reflection. And then if the A value, the absolute value of A, I meant to do absolute value of A. If the absolute value of A is greater than 1, was that a stretch or a compression? Greater, so think about greater than 1, so you're stretching it, right? So it's a vertical stretch. And then if it was between 0 and 1, so 0 less than absolute value of A less than 1. If it's between 0 and 1, is a compression because this is between, okay? So compression. And then our H and our K told us if it was a left to right, up or down. So if you think about the general format right here of the formula, H is always next to the X. And which direction does the x-axis go? Left to right or up and down? X-axis is left to right, so that means H goes left to right because it goes with the x-axis, okay? So the H value tells us, I'll just do this. So H goes left to right. How do we know if it goes to the right? If h is positive or negative? Positive. So if I have a positive h, I gotta go to the right. If I have a negative h, then we go to the left. Okay? And then our k value then is the up and down. So if k is positive, we go up. If k is negative, we go down. Okay, so in this case, we would say then, is this a vertical stretch or a compression? The 3. It'd be a vertical stretch by a factor of 3. And then because it's negative, it's an x-axis reflection. And then we would go, h is negative, so we go left 5 units. And then down 4 units because it's negative. Okay? All right. So for today, we're going to have to be graphing square root functions. So we need to draw the parent function first. So for the parent function, we're going to have to plug in. We're going to have to plug into the equation, which is over here. The f of x equals square root of x. That is the parent square root function. And if you remember, the square root functions have a restricted domain for the positive values. X has to be greater than or equal to 0. That's the restricted domain. So the domain is restricted to x greater than or equal to 0. That's why the first value of x is 0 here. And then the other values in the table have been chosen because they are perfect squares in the domain of the function. Why? Because we're going to take the square root, so you want perfect squares, okay? So what that means is like 0 squared is 0, 1 squared is 1, 2 squared, oops, I put 4, I was thinking it's 4, 2 squared is 4, 3 squared is 9. So these are my x values. That's where I got these over here, 0, 1, 4, 9, okay? Oops. Okay, so we're going to just plug it into the equation. We're going to plug in x of 0. So this is the square root of 0, which is going to give us what? Square root of 0 is just 0. So my coordinate point is 0, 0. And then let's do 1 now. So if I plug in the square root of 1, that's going to be what? 1. So my coordinate is 1, 1. For 4, if I plug in the square root of 4, that's going to give us 2. So my coordinate is 4, 2. And if I plug in 9, that's the square root of 9, which is 3. So my coordinate is 9, 3. So those are going to be my 4 key points. I have 0, 0, 1, 1, 4, 2, 9, 3. These are the key points for square root functions. Okay, so let's go graph that. We're going to go to 0, 0. Remember the square root functions, they have an end point and then they go on in another direction curved. So the first point is always the end point. So in this case, the 0, 0 is the end point in this example. All right, so then I'm going to go to 1, 1, 4, 2, so write 4 up 2. And then write 9 up 3. So at the 0, 0, that's my end point. So I'm going to start there, and then I'm going to curve it in the direction of the points. And then I'm going to put an arrow at the end, only on one side, not over here because that's an end point. Okay, so that is the parent function for the square roots. We're going to be transforming the parent function. We're going to be moving it on a graph for transformations, okay? All right. I don't know if you guys still need that or not. I don't really see anybody writing anymore. Let's look at the concept for today. Okay, so in order to graph a square root function using transformations, you guys have to remember or calculate the 4 key points of the parent function. So those are the 4 key points that we just talked about. You guys have to remember these 4 points. Or if you don't remember them, you need to be able to know how to calculate them, okay? So basically the y values go 0, 1, 2, 3, and then you square them, and that's the x's. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, okay? All right, so for the steps here, steps to graph the square root functions, you need to know the parent function of here because you need to know where A is at. You need to know where H is at. So A, I'm going to stick to red. H, I'm going to use blue. And then K, I'll be using pink. But don't forget for H, you have to take the opposite sign. So the opposite of H. So step number 1 is to find the values of A, H, and K. So you need to know A, H, and K from the equation. Ah! I need you to like put it in the back next time. Okay. That sounded bad. You need to put your bag in the back. Never mind. Okay. So step 2, you're going to use the 4 key points. So that 0, 0, 1, 1, 4, 2, 9, 3. And then you're going to use transformations. So using transformations, the transformations is this. X plus H, 8 times Y plus K. Okay? So anytime you see the word transformations, it means you do X plus H, 8 times Y plus K, okay? And then once you have your coordinates, you're going to graph the transformed points, and then you're going to draw a smooth curve to represent the function. So let's look at an example. So example number 1, please copy that equation. G of x is negative 2 times the square root of x plus 3 plus 4. Okay, so my very first step is again to find A, H, and K. So first, find A, H, and K. So again, A is going to be in the front. So A in this case is negative 2. My H is always going to be next to the X under the square root, though. It has to be under the square root. And don't forget you have to take the opposite sign. So that H is going to be what? Negative 3. And then our K value is at the end after the square root. So in this case, it's going to be 4. All right. And then my step number 2 is to take my key point and I'm going to use transformation. So I'm going to be making 2 tables here. I'm going to take the x values and I'm going to go add h to all of my x's. And then I'm going to take my y values and I'm going to multiply by a. And then I'm going to add k. That's going to be my first table. And then the second table is going to be the new coordinates. So I'm going to take x and the g of x. I'm going to need those 2 tables there. All right, so step 1 to find a, h, and k. Step 2, you're going to take the parent function, the key points, the 4 key points. And I'm going to put them under the x and the y. So my x coordinates is 0. My y is 0. So 0, 0. The second coordinate is 1, 1. So I'm putting it underneath the x and underneath the y. 0, 0, 1, 1. And then I got 4, 2. And 9, 3. All right, then I'm going to take the h's and I'm going to add them to x. So my h in this case, again, was -3. So I'm going to go subtract 3 to all of my x's. And then my a times y plus k, I'm going to multiply the y's times a. So in this case, a is -2. And then we're going to add k. And in this case, k was +4. So we're going to go add 4 to all of those values. And then my second table is basically just the calculated points, okay? So for example, what is, trying to see, I'll use purple, I guess. 0 minus 3 is -3. 1 minus 3 is going to give us -2. 4 minus 3 is 1. And then 9 minus 3 is 6. For the y's, I have -2 times 0. That's going to be 0. Plus 4 gives us 4. Then the next one, -2 times 1 is -2. And then -2 plus 4 is 2. -2 times 2 is -4. -4 plus 4 is 0. The last one, that's -2 times 3 is -6. And then -6 plus 4 gives us -2. Okay? All right, you can definitely do that in your head, mental math, but I know a lot of people struggle with mental math. So if you have, I forgot to take the calculators, put them out. So I do have calculators. I'll put them out in the next example if you want to use them. All right, notice the graph doesn't have an x and y axis. That's why you have a ruler, because you have to draw the x and y axis. However, before you start drawing it, you have to analyze your values and see where to put the x and the y axis, okay? So if we look in this example, my x's have to go from -3 to 6. So I need to give myself some space for -3 on the left side. And then I need to make room for 6 all the way over here, okay? So I'm going to move my y-axis towards the left side enough to where I still have -3 on that side, okay? So you're going to grab your ruler, which I don't know if I have a line tool. Oh, I do have a line tool. I've never used the line tool on here. So you're going to go maybe on the 4th one. I don't know how to use this thing. Can I just drag it? Ooh, that's cool. Okay. It doesn't go to the line. Oh my gatos. It skips over it. I guess I'll just draw it. So use a ruler, please. I don't have a ruler tool on here, so I'm just going to freehand it, and it's going to look horrible. Yeah, that looks bad. So again, why did we put the line here? Because my x's have to go to at least -3 on that side, and then I need to have at least 6 towards the right side, okay? Then for the y-axis, my y values go from -2 to 4. So I only need like 2 spaces down here, and I need 4 up here. So that one is good to just put it in the middle or towards the middle. Because we only need to go from like -2 to 4. This looks horrible, man. I need to learn how to use the line tool on this thing. Okay. And then anytime you draw a graph, you need to draw the scale, like the little numbers, okay? You don't have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can draw a little line, but at least tell me some of them. So I'm going to go put a tick mark at the 1, the 2, and then I'll put my 3, and then tick at 4, 5, and then write down the 6, and then 7, 8, 9, and then -1, -2, -3, and then 1, 2, 3 for the y's. 4, 5, 6, and then -1, -2, -3. Again, you don't have to go write every single number, but you do have to show me somehow what your scale is. So my scale, I'm just going by ones. And then don't forget that the first point has to be your end point. So this -3, 4. That one has to be your end point. And then the rest of them you just graph on, but when you curve it, you're going to curve on the opposite side of the end point, okay? So -3, 4, -3 means left 3 and then up 4. The -2, 2, that means left 2, up 2. So left 2, up 2. And then 1, 0, I'm going to go right 1 and stay at 0. And then 6, -2, I'm going to go to the right 6 and down 2. Again, this -3, 4 is my end point, so that has to stay as an end point. Do not draw an arrow on that side. Just start the curve from that point. Curve downwards. And then on the other side is where you draw the arrow. Okay? And then this is the function g of x. So I'm just going to label it g of x. And then how can you check if you did it right? What does that negative mean? X-axis reflection. This flipped. It's curving downwards now, so it did an x-axis reflection. The 2 tells me that it's a stretch, so I can see it's kind of stretched out because it jumped 2 boxes instead of jumping 1 box. And then the -3 tells us it went to the left 3 times. So from the origin, it went to the left 3 times. And then it went up 4. So 1, 2, 3, 4. So I can see that we did it right. Okay? All right. The next one is a practice problem. So I want you guys to practice this one. G of x equals 3 times the square root of x minus 5 minus 1. Before you start doing the whole table thing, first remember to go find a, h, and k. So I want you to do that first. Talk to your group before you guys get started, because if those 3 values are wrong, then your whole thing is going to be wrong. Okay? So talk to your group really quick. What are those 3 values? All right, what did you guys say? What's A? 3? And H? Positive 5. Good. Positive, you gotta switch the sign. And K is negative 1. Good. All right, so you guys are doing this one? Okay, so on your table, don't forget you're doing x plus h, 8 times y plus k. Oh, yes, and there's calculators over there if you guys want calculators. Okay, and don't forget your coordinate points are 0, 0, 1, 1, 4, 2, and 9, 3. All right, so go ahead and practice this one, and then I'll show you guys the solution afterwards. All right, guys, I did not have a chance to go walk around. I like walking around to checking, but I didn't have time. So I double check your work. Your coordinates, you should have had 5, negative 1, 6, 2, 9, 5, and 14, 8. So because you don't have any negatives for the x's, and you need to go all the way to 14, you needed to move your y-axis towards the left side. And then for the y-axis, you only need the negative 1 at the bottom, and you need to go up to 8. So you can move the x-axis towards the bottom, so you have enough for 8 at the top and negative 1 at the bottom. Don't forget your end point. You should not have an arrow at the end. That should just be an end point. The arrow goes on the other side. And then we would label this as g of x. Okay? And then for checking, my original, the parent function is at 0, 0. And I want to check, did I get to where I was supposed to? So the 3 tells us it's going to be a vertical stretch by a factor of 3. So that's going to move up to 3 here. I'm stretching it at 3. And then my h of 5 means I'm going to go right 5 times. So 1, 2, 3, 4, 5. And then I'm going to go down negative 1. Did I do something wrong? I was supposed to end here. Did I do something wrong? Let me see. 0, 0. Oh, duh. Because 0 times 3 is still 0. Oh my gosh, Miss Figs. Come on. So it should have stayed at 0, 0. Then you go right 5. So 1, 2, 3, 4, 5. And then down 1. So that's how you can tell if you did it right or not. Okay? Alright. That was a practice problem. So there's a solution. Oh my god, I spent all that time drawing it and doing it because I thought that I didn't have the solution, but I could have just showed you. So I would have had time to walk around. My bad. Next time. Alright, this one, can you copy this example? G of x is 0.5 times the square root of x minus 4. Now we're doing this one together. All right, tell your group really quick what are A, H, and K. All right, so on a count of 3, tell me what's A in 3, 2, 1. 0.5, good. H, tell me in 3, 2, 1. Positive 4. And K in 3, 2, 1. 0. Awesome. Okay. So for the table, same thing. We're going to do X plus H, H times Y plus K. Okay, and then we're going to have our another table, X and G of X. What are my 4 key points? The first one is 0. Well, just the coordinate together, so it's 0, 0. The next one's going to be what? 1, 1. The third one is 4, 2, and the last one is 9, 3. Good. So we're going to go add H, which is 4. And then multiply by A, which is a 0.5. Multiply by a 0.5 is the same thing as dividing by a half. And then my K is 0. You don't even have to do the plus 0 here. You can just ignore it. But I just did it just so you can see what's happening. Okay, so let's calculate that. 0 plus 4 is going to give us 4. 1 plus 4 is 5. 4 plus 4 is 8. And then 9 plus 4 is 13. Then for G of X, 0.5 times 0 is just 0. Anything times 0 is 0. And then 0.5 times 1, 0.5. And then 2 times 0.5, 2 divided by 2 is 1. And 3 divided by 2 is 1.5. Or a 0.5 times 3. Alright, my X values, I don't have any negatives, and I need to go out to 13. So you want to move your Y-axis all the way towards the left side because you don't need any negatives. So my Y-axis, I'm going to draw it here. And then my Y values, I only have positives from 0 to 1.5. And because of the 0.5s, I'm actually going to make my scale go by a 0.5. So I'm going to draw my scale towards the bottom a little bit. Because my scale is going to be a 0.5 instead of a 1. Okay? Don't forget, you got to tell me your little scale on your graph. So 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, and 12, which means my last one there is 13. And then for the Y-axis, I'm going to go by a 0.5. So 0.5, then 1, then 1.5, then 2, 2.5, and 3. Okay? So let's go graph that. Don't forget again, 4, 0 is the end point. So 4, 0, go right 4, stay at 0. Go right 5. And then up to the 0.5. And then 8. 8, I'm going to go up to 1. And then the 13, we're going to go up to 1.5. Start at the end point and just curve it over and put an arrow on the other side. And this is G of X. So you can tell in this example that the graph is actually like smushed together. So it's a compression. It's a compression of a factor of 1/2 because of the 0.5. I can see that the function normally is at the origin here, so I moved to the right 4 times, and it didn't move up or down because it's still on the x-axis. Okay? Yeah. Okay. Next example, you guys are trying again. Be careful with this one. Again, before you get started, because this one is a little bit tricky, I guess. Let's have you have a conversation with your partners, your group. What are A, H, and K here? Be careful. What are A, H, and K? Yeah, sorry. I just... Sorry, I'll do it in a second. Okay, what's A? -1. H is going to be what? 0. Good. And then our K value is going to be -2. Good. That's because the -2 is on the outside of the square root, so it's a K. All right, go ahead and try this one. This is a practice problem. Thank you very much. All right, guys. So here's the solution. Shh, on my bad. You guys should have had 0, -2, 1, -3, 4, -4, and then 9, -5. And then your curve should have been going downwards. And then don't forget to draw your arrow like at the end over there. Okay? All right, no homework over the weekend. We're just going to do it in class on Monday. Okay?